Okay, so I'll give you a little overview of what to expect on this test, which is going to cover sections 8.1 through 8.5. We actually have one more section to cover in this topic, but it's not one that we'll test on. You'll just have a homework assignment for it. It's just kind of a hard one to test on based on what it's about. So you'll see that when we get into that topic. But going back through the basic integration things we did back in 8.1, some of the things you can expect to see, see some problems where you're doing some basic substitution. So you may have an example or two of that. We also had ones where we suggested breaking up the fraction and working the problem out that way. Now, something like this one here, remember we had to do some maneuvering stuff here. Probably you wouldn't run into that really because that's covered with the inverse tangent, the tangent substitutions that we did later. So a lot of the stuff we did here was a little easier later on, so that's covered later. So probably wouldn't really have an issue with something like that. Of course, we could run into a long division one. That's definitely a very reasonable one. Of course, you also saw that later on. The long division when we were dealing with our partial fraction decomposition. So you could definitely have one where you don't have to do a partial fraction decomposition. And of course, we talked about completing the square. Most of this stuff really don't worry about too much from that section because that's going to come up later in 8.4 with our trig substitution. So I would not worry about the completing the square issues. We did a couple of examples with those. So I wouldn't worry about that, this kind of stuff on your test from this section. It would be something that's coming up as part of the 8.4 section. And of course we had our multiply by 1 idea that comes up with the sine and cosines. Very common type of idea. And there could be a hard one, but it would just like be one question, and that's less likely. Right? Kind of brute force and hope type stuff. So mostly just basic integral ideas. Long division, definitely an idea. Breaking things up into pieces, that could be kind of an idea where you need to do something like that. This e to the x one, multiplying by 1 type idea, definitely a common technique as well. And again, like I said, the basic substitution ones. So that's kind of what you're looking at there in 8.1. And in 8.2 is where we brought in the idea of integration by parts. So you expect to have a few problems where you're working with integration by parts. So expect to run into some of those. Remember, the idea is that if we have an integral of u dv, we rewrite that as integral of uv minus the integral of v du. And the hope is that the integral of v du is either something you can compute or something that could be reduced further so that we can do our integrals. So just trying to do a quick little pop back over to 8.2 and some of the examples we did. Again, a really common idea is positive powers of x are good choices for u. Again, there are times when that rule doesn't hold. Ln is a common example. Typically, that's the time, especially Ln if it's with powers of x. We usually like to use Ln as the u variable because its derivative helps us to reduce things out. But you can expect some basic ones with powers of x, like we did here with x e to the x or x squared sine, or even with our x secant. I would expect one of these kind of problems where you have you basically carry the process through and it actually takes you back to where you started, so that we're able to then solve for the integral in terms of the other stuff we have. So that was that kind of loopy one. Definitely, could run into, something with the ln, or, with our inverse trig functions. Definitely a possibility as well. Okay. Then in 8.3 is where we brought in our trig integrals. So I will give you the reduction formulas. So they're there for you to make use of. You do not need to memorize them. That's an absolute waste of time. I will provide those reduction formulas to you. But remember, we don't always just default to reduction formulas. If we have integrals involving sines and cosines or tangents and secants, right, then we have other ways of handling them that don't necessarily require the reduction formula. So as an example, consider the integral of sine cubed x cosine to the fifth x dx. Remember, if we have an odd power on sine or cosine, then what we want to do is strip one of those off. Strip one of those off to go with the dx. So here I can do that with either one. Since cosine's a bigger power, that's going to leave more stuff left over. So what I would do here is stripping away from the sine, with the idea that I'm going to be doing the substitution u equals cosine. So if I do that, then du is going to eventually call for a negative cosine to go with my dx, or negative sine, sorry, to go with my dx. So with that in mind, I'm going to account for that right now, kind of ahead of time, before I even have gotten the problem to the cosine. I know I need a negative that I don't have, so I'm going to take that out. That'll leave me with a sine squared and a cosine to the fifth. Now I have my minus sine x. Then I need to go with my dx. And then we can take the sine squared, all the remaining even powers. In this case, it's just the sine squared, and rewrite that in terms of cosine. Right? That's just 1 minus cosine squared. So simplifying here, we'll have a negative out front of cosine to the fifth x minus cosine to the seventh x, and we have a minus sine x dx. So everything's set to change this over to the integral of u to the fifth minus u to the seventh du, and the negative still just hanging out there, so we do minor integration. And I'll have negative 1/6 u to the sixth plus 1/8 u to the eighth plus a constant, and then finally convert back to cosine. Okay. And that'll give me negative 1/6 cosine to the sixth x plus 1/8 cosine to the eighth x plus our constant. Okay, so that's just an example of a sine cosine integral, working that out, leveraging the fact that we have a odd power sign that can be pulled off, so that when we convert everything over to u equals cosine, right, then the substitution carries through and we're able to do the basic integral. Of course, if they're both even, that's when you kind of scream a little bit, because then you're going to have to convert them over to something you can work with, which the ideal way then would be to try to convert everything either to sine or cosine, and then use your reduction formulas. And then we had similar ideas as well with the tangent and secant integrals, which you can again find more examples of. So again, there's all of our reduction formulas. Those will all be provided for you to use. And then remember, we had our rules as well with tangents and secants, working out integrals with tangents and secants. Okay. So again, we're looking for tangent secants, right? Either being able to strip off an even power of secant, or having an odd power on the tangent that we can strip off to go along with one of the secants, and then convert everything else to secants and use that substitution. So those are the ideal ones, the easy ones. And of course, there's the scream situation. Probably wouldn't give you a scream situation on the test, so don't worry about that one. It would be something a little easier than that. And then 8.4 is where we talked about our trig substitutions. Our trig substitutions. So remember, if it's a squared minus x squared, we use the substitution x equals a sine theta. If it's a squared plus x squared, we use the substitution x equals a tangent theta. And finally, if it's x squared minus a squared, x squared minus a squared, then we use the substitution x equals a secant theta. So you can expect, to see some integrals where you're going to need to do those substitutions and then do some work after that, as we came across in 8.4, as we came across when we dealt with problems out of 8.4. All right, you can go through, here was one that we eventually used our tangent, and we then had to work out an integral of secant. And remember, after we worked that out, there's the then convert back step, which is when we take our relationship, solve it for the trig function, right, and then set up our diagram, and then we have to convert back. Okay, so you had some various examples that we did in class, and of course you've done as well. This is a situation where you probably will run into one where you're going to have to complete the square. That'll result in something. We did a couple different ones there as well, where we have to complete the square. So I expect to run into something with completing the square, and that would be the place with these trig substitutions where you would do that. Okay, and then that brings us to 8.5, what we've just been talking about with the partial fraction decomposition. And what I'm going to do with that on your test, because these problems can be so extremely long, is you're going to be dealing only with ones that involve on your test linear factors only. Okay. Just because otherwise they just get so exhaustingly long. So exhaustingly long. So because those can be so exhaustingly long on the test, again, you only have linear factors. But to make sure you do understand how to do them, you will be turning in 2 problems, which will count as problems on your test. And those are problems number 48, which is this here, integral of x cubed plus 2 over x cubed minus 2x squared plus x dx. Problem number 48 from the e-text online. So again, you can get that, but I'm just giving you the problem. So there it is. Problem number 48. You can see that actually does involve linear factors as well. Actually, if you factor it, you're going to have a repeated linear factor. But 48 is also faced with another issue initially. And that is the degree of the numerator is the same as the denominator. So you're actually going to have to begin 48 by doing a long division step first. And then continuing on from there. The other one I'm going to give you is problem number 50. 8 times x squared plus 4 over x times x squared plus 8. So here you're dealing with a quadratic factor in that denominator. So that's the second one. And those are two you're going to turn in. And again, when you take the test, just turn those in. And so that'll kind of count for the harder stuff, just because they just take a long time, and I wouldn't want to put you in a situation where you're in a time crunch and you have to try to work all these out. So those you're able to do at home. Use your notes and stuff for those, and then just turn those in, okay, when you go to take your test. Okay, so those are going to be two problems that you'll turn in when you go in to take your test, just like with the last test. And those will count as just two questions on your test. Okay, so that's the outline of what to expect as far as with the test. If you do find you have other questions or anything as you're preparing, please always feel free to ask me, get some help.